Okay. So like I was saying, let's wait for it to load. Okay, so I want you to notice this real quick. So I have a matrix in here, right? Let's say I'm going to do one of these row operations, okay? Let's say I'm going to do, let's go second matrix, math, and I'm going to do a row swap. I also said yesterday that we don't really use D, but D is like the option if you used F, but you multiplied by 1. That's why it's not really necessary. But if you want to use that, it's totally an option. So D is like F, except the multiplier is 1. Okay? Let's do a row swap in this case. So to do a row swap, I have to tell it the matrix first, so it knows which matrix to go to. So I'm going to go matrix A. Here's my names. And I'm going to say swap row 1 with row 2. Correct? And if I hit enter, it'll do that for me. See that? Yeah. But I want you to look at something. If I recall matrix A again, it's still the original matrix. You see that? So it's giving you a superficial thing so that you can copy it and do what you need to do. If you want to stay and be somewhere, what you'll need to do, once you have that, you're going to push the stow button. It's going to store somewhere. It's right here in the red, next to my finger. And I'm going to store it to the next available matrix. Or you can store it to itself if you want. Like I did it to every, I started to a new matrix every time. That way if I made a mistake, I can go back and check. But you have to store it, if you don't want to do that, you'll store it back to itself. What do you guys want to do right now? Start to a new matrix? Yeah. All right, cool. So all I do is go back and I grab a new name. So I'm going to go over to matrix. And I'm going to say, now I've stored it to matrix B. So take whatever you do here and store it in matrix B. I push enter. There's my row swap again. And now if I recall matrix B, see how it's stored now? It'll give me that same matrix with my row operation. So you'll have to do that. Now again, you can overwrite the last matrix you had, but you have to put that stow button piece on there, okay? Simple enough? All right. We also talked yesterday about that there is the REF and the RREF on there. The row echelon and the reduced row echelon. Use those. Use those. But understand that you also have to know how to do the operations. Because if it's done on a writing final, you can't. Someone said, hey, you know what, it's taking me a long time to do my homework because I have to show my work. If this is your work, then you need to tell me what buttons you pushed. And that's your work. That way I can verify you went through the right steps. If you're not doing the math, you just said, I went second matrix, went over to edit, went matrix A, changed it to 2 by whatever, 3 by 4, punched in all my values, blah, 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 all that. That is your work. There are been writing finals where if you do that, you have full points. That was your work. Okay? Because it sometimes said, hey, how did you graph this? And if you said, I went in my calculator, 84, I hit y equals, I punched in the equation, and then I went and I did this, totally legit. Those people that love the graphic method. Okay? There's nothing wrong with that. What's up? No. I don't think so. Pretty sure there is this. Okay? So, all right. Everyone's cool with that? So, hopefully that helps you with the questions that you have, because it does take time. If it's not, then we'll come back to that. I want to get through this because I'm covering 2 sections today. What's up?
On our writing final stuff, can we say like what buttons you press on the calculator? That can be like.
That's your work. Yeah. Definitely. Okay? Okay. Yeah, that's totally legit. It's a tool. Okay? And then. Okay, cool. So, we've been working with these systems. You were doing the row operations and all that good stuff, right? So you can go through all those processes. This is more of the same bit, okay? However, there are other types of systems. Some systems will have a solution. Yay, I got a solution, right? But you guys know that there are systems that have no solutions and systems that have infinite solutions, okay? So this is what we're going to be looking at. We're going to be using the Gaussian rule for elimination without a unique solution. more than one solution, and then we're going to try, if we have time to solve problems, then we will. Okay, I really don't know if we will, because I want to jump on to the 8.3. Okay, I really want to be done. We have 1 week left, right? After today? Yes, thank you. So let's do this. Now, I'm just going to show you the easy way. You can go through the processes if you want. It's totally up to you, okay? But I'm going to use my handy dandy calculator because I love my tool. So I'm going to go second, matrix, over to edit. What's up? Next week is the last week of instruction. The week after that is finals week, isn't it?
Yeah.
Okay.
I was like, no.
I don't really consider the last, like finals week, it's not a time to be teaching you.
Yeah.
We should be done. So next week is the last week of instruction we have. In my mind, finals week, you're not, yeah, you're reviewing, you're not learning stuff. You shouldn't be learning stuff, hopefully. Huh?
Yeah, we have extra credit.
What is this extra you speak of?
I know. Mercy. Yeah, give us some mercy.
Oh, actually, you know, I'm going to pretend I didn't hear that, and I'm going to move on to the lesson.
What?
Because there's a policy in the math department that there is no extra credit.
That's dumb.
We do not have extra credit in the math department. All your credit is in the course. So, stop saying that. I just said it. Because we allow you to go all the way up to November, whenever, to do your work, there should no reason for you to need extra credit. Because whatever credit you need, you could have gone back and done it. That makes sense? That's why so it's not like we're trying to be mean or anything. There's no reason for extra credit. The course is your credit. Okay? Moving on. I need to punch in my matrix. Where's my problem?
Oh my gosh, that was already on mine.
Okay, so do you guys need a second to copy this? That's the system I'm working with. That is the system I'm working with. So go ahead and write this down real quick. Yes. No, there's more. There's more.
So we're doing 8.2 as graded A?
Yeah, we're doing 2 and 3 hopefully. There are, how many sections are in here? Oh, there's 5. So Monday we might do 4 and 5. Then we'll be done. Then we can test and then study for the rest of the time. Because you still have to take that test, right?
Yeah. That's why Tuesday.
No, Tuesday will be your chapter 7.
Final.
So Friday you might be doing your chapter 8.
So then when's our writing final?
Tomorrow,
Oh, yeah, okay.
right?
Yeah.
No.
Alright. Sounds like we're done here. I'm going to move back to my calculator. And I'm going to punch in my values. Well, I'm not going to punch them, but I'm going to type them in. So it looks like we had 1, 2, 3, right?
Yes.
If I'm not mistaken, if I remember correctly. No, it was 1, -2. Someone read me the values. 1, -2, -1, and then 5, 2, zero,
Yeah.
three,
-4.
-4, -1,
Yeah. And then a 1.
and then 1. Cool. All right, so I've got my matrix in. I want to solve this thing. I want to make sure that you guys are showing me your professional courtesy here as we come into finals weeks. I already have my matrix in. Hopefully I put it in correctly. you can have a mistake there. So make sure that you check and you double check, and hopefully I got it right. I want to go into matrices. I'm going to use a shortcut here because I know that I'm not going to waste my time with the row operations. And I'm going to go with the RREF for now. I want an RREF matrix.
You mean REF?
Yeah, what did I say?
You said RREF.
I just like the way it sounds. So I have my REF here. So here's my solutions. Now, if you don't like this, maybe you like fractions, you can go over to math, hit the frac, and then push enter, and it'll give it to you in fractional form. So here I have reduced row echelon form, right? No, sorry, I have row echelon form. Even if I did reduce row echelon, I would notice something very unique here. Okay, now think about this. This is representing x's in the first column, y's in the second, z's in the last, correct?
Yeah.
So what pops out at you as being weird here?
There's no value for Z.
If you look at the very last column, I'm saying that 0 x's plus 0 y's plus 0 z's are equal to 1. When does 0 plus 0 plus 0 equal 1?
Never.
Never. So what type of system is this? It
It's
has a specific name.
It's inconsistent.
It's inconsistent. It is called inconsistent.
system.
Inconsistent. So if you notice that on your calculator, don't be like, well, maybe you do want to go back and check your matrix one more time, right? Double check that that is incorrect. But then if it is, then you've noticed that weird line where you've got a bunch of zeros equaling something, then that's not right. It is an inconsistent system. Therefore, the solution is an what should you put in for your solutions? CBD can't be done. No, you put in the empty set. The solution is the empty set. It's null. That cannot be solved. It is an inconsistent system. Okay? All right.
I got some crispy.
You guys let me know when I can move on. We're good? All right, let's move on to the next problem then. And I think this was, so here's our next system. Go ahead and write that down, punch it in. I wish I had my remote control one. Rocky roller.
For a second, I was like, that looks like the same problem.
What?
It looked like the same problem, but it's not the same problem.
Like I stood up, I walked, my leg was like this, and I went this way, and I was going this way at the same
Are
time.
you just learning to walk?
He's up in his
walk like 3 times.
I can't speak your language.
I do. Are you in band? Check your smiley face a little. What's up? You mean put the formulas into the matrix? Oh, I'll do it again right now. So it's really as simple as this. So let me clear this up. So I go second matrix, right? And so this is where the names are. This is kind of like the variables. So under the names one, that's where we grab the stuff. Over here in the math is all our operations, and then the edit is where we can define the matrix itself, or those matrices. So if I want to if I wanted to do REF again, one more time. So if I want to do this, I've got my command, right? I need to go grab that variable, that matrix. So once I go back into matrix, let me do it with matrix B this time, okay? So I'm just going to highlight matrix B under names, push enter. And then I push enter one more time, and it's going to put that into REF for me.
I did it last time and it said that it was 0 on here.
What did it say specifically?
It had the little exit thing.
All right, when it happens, let me know, and then we can try to troubleshoot what happened. Because sometimes what happens is you have your whole matrix, and you're putting it in, and you don't push enter on the last thing, so there's no value there, therefore it doesn't know what to do with it. It doesn't count it as a 0, it counts as an empty. So you have to push enter in order for it to register it. So that happens sometimes. All right, what was I doing? Matrix. I'm going to go ahead and enter my values into matrix A. It's a 3 by 4, correct?
Yeah.
Okay.
That's a 1.
So,
Read it off here.
oh, cool. What is it?
It's 1,
1,
-2,
-2,
-1,
-1,
5,
5,
2,
2,
-5,
-5,
3,
3,
6,
6,
1,
1.
-3.
I don't think I got a 1.
No, you didn't press 1.
Is that supposed to be 1?
Yeah, it's supposed to be 1.
1,
-3,
-3,
4,
4,
and 1.
and 1. Okay, cool. So we're good. All right. Second, quit. I'm here again. I don't like to see my old work. I'm going to push clear a couple times here. All right, so second matrix, I want to reduce, and you can also select the numbers if there's a number available. In this case, it's going to be easier just to go to A, because I'd have to go alpha A. So enter, and I want to reduce, what matrix is it?
A.
Matrix A. All right, cool. Now, what pops out as being special in this matrix to you?
0,
Is there anything wrong with that last line of code?
No.
No.
Not really. Code. The last equation. It's really not wrong, right? Well, let's talk about that line first. It's a true statement. Okay? So what's really going to happen? This is telling you that this system is, what's the special name for it? It's not inconsistent.
Is it dependent?
It's dependent. It's going to have infinitely many solutions, but this system is going to be dependent on something. Okay? So here's what you're going to have to do. You're going to have to go back into equation mode. All right? So I see this. This is okay. All this is telling me that it's a dependent system. I'm going to have infinitely many solutions. I still need to get solutions for X and Y and all that business, okay? All that jazz.
Yeah.
But here's what I know. I do know that Y minus 5Z is equal to
4.
4. Right? If you translate that second equation,
That's what that
that's what it is, correct?
Yeah.
And the top one says, it says X minus, what is that, 5 halves? 5 halves X plus 3 halves, not X, this should be Y.
That's Z.
3 halves Z is equal to 3,
Yeah,
right?
it's gross, you're right.
All right, that's okay. Doesn't matter really. Now, here's what I know. I know that Y is equal to 4 plus 5Z. There's my value for Y. Questions on that?
No.
Okay. How can I get the other part?
You would plug.
How can I get my X?
You would plug Y into the.
Yeah, I'm going to plug my Y value into this Y, and I'm going to solve that. So X minus 5 halves times 4 plus 5Z plus 3 halves Z is equal to 3.
Yeah.
Oh my, oh my. Do I need to switch that over to the other one?
Possibly.
Maybe I should, huh?
Yeah.
What is it? X minus,
5 halves.
yeah. I don't know what I want to do. I don't know if I want to go back to decimals or, let's go 5 halves. What was it, 4 plus 5Z?
Yeah.
4 plus 5Z
Plus 3 over 2Z.
plus 3 over 2Z is equal to
3.
3.
Yeah.
All right. Let's distribute. This is going to be minus 20 over 2, which is, oh, that's just 10, right?
Yeah.
So minus 10 minus 25 halves Z plus 3 halves Z is equal to 3. X minus 10 minus 22 halves, correct?
Yes.
Z is equal to 3,
Bigger than 11.
right?
Yeah.
Yeah.
So I'm gonna move everything that's not an X to the other side. That should give me X is equal to 13 plus 11Z, correct?
Yeah.
Yeah.
Cool beans. So
Yeah.
yes or no?
Yes.
Cool. So here's my solution. My solution. What's my value for X? 13 plus 11Z. What was my Y value?
It looks like
4 plus 5Z. And then what's my last one going to be?
0.
This system depends on what the value of Z is going to be.
Oh my god.
Does that make sense?
Yeah.
So there it is. X, Y, Z.
What's the word?
That's Inception. That's pretty cool. Yes, those are the answers. And they're infinite, but what does the answer depend on? The value of Z. Always. The matrix is right up here.
What would be the question?
Yeah, the question would be solve this system. And they might say, actually they might just say solve the system. You figure out that it's a dependent system, and you have to plug those at the very bottom. Because remember, the solution is going to be a set, X, Y, Z, in order to triple. Yeah, it can, because it's a dependent system. Remember, there's consistent and there's inconsistent systems, right? This is technically consistent, but it's dependent on Z. Not until we know what it is. Yeah.
Oh, that makes sense.
You could try to solve the system with elimination, and you would still come to the same conclusion. Hey, mucha atención. So I'm having a conversation with Jen here, and she's asking about why REF exists. REF is simply a tool that we found that will work. The calculator is doing the work for us, and we could do it with raw operations. If you try to do this with elimination, you would end up with the same thing. At some point, you would get x equals x or 0 equals 0. Once you find that, then you're going to say, oh, this is a dependent system. Then you go back to the equation, you try to figure out what y is equal to, what x is equal to, all depending on the values for z. It does, and that's why I say that. I love saying that. Right. Well, yeah, I see what you're saying.
No.
So, let's do this real quick.
Wouldn't RREF give you?
It would give you something funkier. Let me go
Yeah.
back to.
Like in this instance,
Let
it
me
would
clear
give you
this
something
ink.
weird, like a weird.
What I want to do, second, matrix, right?
Yeah.
Math, alpha, B, matrix, A.
Yeah.
So you would still see that weird line of code, see that?
Yeah. You get the same exact thing you got there.
But you go through it, and, yeah, so
So if you really
either
want,
one of them. But we usually test the REF first. Because you'll see that inconsistency at the bottom. But yeah, RREF will get you there as well. You're going to get something weird. The only thing I see different is, are those the same?
Yeah, it's the same.
Yeah,
answer.
see how here this is kind of weird? But you'll still get there. So you can do whichever one you want. I like our REF better.
It just gets you to your answer.
But the way they want you to do this one, see at this point, did you try plugging back into here? You got the same thing? Yeah, so you'll get the same. It shouldn't be any different.
So what would be the difference between choosing REF and RREF?
You're gonna have different intermediate math. So you'll still end up with this y equals business, but when you plug over here, it's gonna be different, isn't it?
It's gonna be x equals.
Because this would be what, x, what did we get?
X
X
equals
plus something y, which is gone, because
Yeah.
that's what y is,
yeah.
minus
11.
11, z is equal to 13.
Yeah.
And so you're gonna get 13 minus 11z, it's still the same thing.
Yeah.
Right, so this must be so simple. I'm gonna move on. I don't even know where to move on now. You guys threw me off here. Let's move on here. What do we got? So we talked about consistent, inconsistent. We got all those zeros. Here, try this one. No. Mr. Ross? deposit will be here.
Where did it go?
1, 2, 3, 70, 1, 1, 1, 60.
Just write down the problem and makes it. Oh, what the crap?
I'm gonna try to do it with the RREF like you did.
Yeah, I want to see because with REF you.
The RREF doesn't work this time?
I was doing the review, the REF.
No, REF just that's what you do with REF. And then try REF. REF came out.
Sometimes the
weird.
REF wouldn't work when I was doing the review.
Yes.
Yeah, that's right. Right.
So there's a good example where your RREF isn't gonna help you. So
Yeah,
so I did the RREF.
Did you?
Uh,
I'll try REF because I don't know.
well, that's RREF.
Is it?
Yeah.
REF.
So according to this is saying that y plus 2z is equal to 10. Therefore, y is 10 minus 2z, right?
Yeah.
And that x is equal to 50 minus z plus z. It's going to try to do a reduced row echelon for you.
It wants zeros in the bottom left and the top right. Like
What? It does. It did.
it did work.
It works.
I was saying REF.
I thought that was the one, but no. It should always work. Because all that RREF, if you think about all that you're doing with raw operations, is you're making all equations either bigger or smaller. That's all you're doing. Therefore, at the end, once they all get simplified, like reduced, they end up being the same equation regardless. Therefore, producing the same solutions. It's like saying instead of putting a 2 in, now it's a 4, which is just 2 times bigger. So if you think about it, that's all you're doing. You're making all equations bigger or smaller based on that first rule of algebra. What's up? You typically, I'm going to say about 99.99%. It's always going to be dependent on z.
Yeah, and then.
Yeah. So in this case, your z should be the z. And every problem that I've ever done, it's always dependent on z.
Yeah, because this one is
Okay.
different.
So here my solution would be 50 plus z, and then we've got 10 minus 2z, comma z. What's up?
Why is it minus 2z? Like, I get why there's a 2 minus z on y.
Here, this is y, right?
Yeah,
So this is y plus 2z equals 10.
yeah,
I got to move this over to find what y equals. So once I change sides, I got to change the sign.
got it, okay.
Okay?
So
Same thing over there with the 1z. It was a negative 1z on the left. When I moved it, it became a positive z.
And that's like our solution.
The solution would be the ordered triple. So what's the value of x?
50
50 plus z, comma,
and
10 minus 2z, comma, z.
Because for Z it's dependent.
Usually these that are the systems that are usually dependent are dependent on z.
Why is Z so irresponsible?
I know. Well, maybe it's so responsible that we have to depend on it.
Oh yeah, I'm like, why are X and Y so irresponsible? I'm sorry. Can't think for themselves.
X and Y must be related to me because I am very irresponsible.
Did you need that? I'm sorry.
Y,
I did this one right, but I don't know why I didn't.
X and Y need to get their shit together.
Whoa, Whoa, watch your words, please.
We have that crap.
Still. Stop. Are we caught up here?
Yeah.
Is that 50 plus 2?
It says
50 plus Z. Sorry. It's this right here.
Are we gonna give you a thumbs up, thumbs down?
You know, just hope you got it.
Huh?
I think you'll be fine. I'm gonna move on.
I think I understand.
Okay. Now, the other class has already done this next lesson.
Wait,
So it's a little bit later for you guys. What's up?
oh yeah. We're doing 8.2.
no,
Yeah,
no,
I-
I know that.
But what?
Skip the other problem.
No, I didn't. It was this one.
There's just 2.
Yeah.
Yeah, so if I push next, it's my, okay? So now you're gonna do matrices. This should go by really fast as well. There'll probably be one thing that you'll have a little bit more trouble with, that you will also need to know how to do by hand. But luckily for you, I'm also gonna teach you how to do it with your calculator, but I can't stress enough the importance of being able to do it by hand, okay? I'm gonna do everything here by hand, and actually I should let you figure it out. You're mean, Mr. Munoz. So? Alright, so today what's up? We're doing matrices. We're going to use matrix notation. I'll talk a little bit about what that means. Talk about what equal matrices mean. We're going to do some operations with matrices. Solve some matrix equations, and then we're going to multiply matrices. And multiply matrices is probably the harder one. It's not that hard, but it can be. And if we have time to model, then we'll do that. We probably won't, because I think you want a little bit of time at the end for something. I think you guys can figure out the modeling part by yourselves.
That's just like the graph.
Yeah, probably more than likely. That's it. What? No, I don't know if we can. Okay. Can I get started?
No.
Amigos, corona esa niña. Can I move on?
Yeah.
All right, cool. Let's move on. Matrix notation. Here's what you need to know. I can have, and I think you guys have seen that already. You recognize it from your calculator, right? This notation means I'm talking about matrix A, and of course matrix A can represent whatever matrix I have in there, okay?
Are you live?
Yes. So we're okay with the notation for matrix?
Yes.
Okay, I want to point out this little bit here that says you have A sub I comma J. Okay? A sub I comma J. That is the notation for specific elements inside of your matrix. I think I said that before, right? It's like an address. So if I said, oh, I'm looking for A comma A sub 31. That's not really A sub 31, that's A sub 31.
Roll call.
Third row, first column. It goes rows, columns, always, okay? I don't know why they don't just say RC.
Okay, so
It just makes sense.
I'm sure there's a perfectly valid reason for that, but I don't know what it is. I don't remember. I'm probably sure.
It says right there.
What's it say?
The ith row and the
Yeah, but she's saying, why isn't it the rth row, cth column?
so wait, if that's
Go ahead.
no, she's talking.
No, that's secondary.
Okay. So in like the 3 and the 1 are they relate to the I, the J, what's the
A is just asking for a specific one. What's the value of that?
so like
It's kind of like saying X or whatever, okay?
A being matrix A or
Yeah, so if I said B sub
so
21,
that's matrix B.
That would be matrix. The element in matrix B,
So,
second row, first column.
so what the number is. It's kind of the element as in what's the number.
Yeah, so the lowercase is the element. So this would belong to this guy.
Yeah, okay,
Yes.
got it. Thank you.
Okay?
So this is only multiplying like an individual, like.
No, we're going to do a couple things. So yes, we'll do that, which will be super easy, but then we'll do matrix times matrix. Okay? So, and again, I don't know why this is not R times C. It's M times N. That's how you define them. It's rows by columns. So if I have a 2 by 3, if I have 2 rows, 3 columns, that would be a 2 by 3. If I have 5 rows, 6 columns, that's a
5 by 6.
5 by 6, so forth, so forth. Now, if M and N are the same, if I have a 5 by 5, then that's called a square matrix. Makes sense, right? Squares have the same dimensions.
Yes.
So if M and N are equal, then you're really working with a square matrix. Simple enough?
Yeah.
Cool beans. I'm going to move on. Wait. Okay. So we're going to let A represent the matrix that includes those elements above. What is the order of A? It's a what?
Wait.
3 by 2. It's a 3 by 2. Okay? What is element A, 1, 2? Negative 2. Swing batter. What is element A, 3, 1?
1. Positive.
Yeah, it's the 1. Anybody have questions on anything right here?
No, but don't move forward.
I can wait.
I was writing.
Got it? Are we good then? All right, moving on. If two matrices are equal, that means that they have the same order. So a 2 by 3 is equal to a 2 by 3. Okay? And you need to know that in order to be able to add or subtract them. Two matrices must be equal if you're going to add or subtract them. Their order has, what did I say? Their order has to be the same. They have to have the same dimensions.
Talk a little fast.
I'm getting excited here because I like multiply matrices. So this is not a bad operation here. But they might even say let this represent A and let this be represented by B. They might ask you to operate this way. Oh, sorry, I missed something, didn't I? A plus B. So you might see the operation that way, and then you'll have to figure out what goes where type thing. Okay, but this isn't bad, right? Let's figure this out. If I'm adding a 2 by 2 with a 2 by 2, what should I end up with?
2 by 2.
A 2 by 2. So I should get 6, 0, 9, negative 10.
Well, how did you get 6?
If you get
Yeah,
6,
how
it
did
should
you
be
get
2.
6?
Oh, I didn't even do my.
Yeah.
What should that be? 2, right? And that should be 0, and that should be 9, and that, yeah. There we go. Much better. Thank you.
C would equal.
How did I get what? I don't know. I think I just looked at the 6 and wrote the 6.
That's funny. Like we did all the other ones like correct. That's funny.
This is not difficult.
So you just subtract the columns.
Right. You have to perform the operation on the same coordinates.
Okay.
So that with that, so forth, so
That's how
forth.
it is, like multiplying.
No. No. Well,
This is how it is with adding and subtracting, right?
correct.
Okay, just, and then
And then I'll tell you what it means with to multiply, because there's 2 different types of multiplying with matrices. There's a scalar multiply, and I'll show you. They're not. You'll be able to tell the difference really easily.
can
Okay.
you divide them or no?
Yeah.
But like, are we gonna focus on like also learning how to divide them?
No.
Okay, so it's not like somebody's gonna ask, hey, what's that?
No.
Okay.
You'll be fine. I can change the slides.
Yes.
Moving on. Can this be done?
Yes.
Yeah. What will we get?
Negative 9.
9.
Negative
No.
9,
No.
Negative 4.
Yeah.
Negative 9.
Negative 7.
7,
Oh yeah, 7.
5, and then negative 2.
This would be 5. Oh, yeah, because it's
Oh, it's subtract.
negative, negative. So, double check my work, please.
It's good.
I gotta write down.
Yeah.
So are you just technically subtracting 3
No. No, these are no longer systems. These are just matrices.
So like they don't represent X or Y.
They don't necessarily have to represent anything. Of course, you know they do, but we'll worry about that when we need to. You know what? Here's one usually where they do, just so that you can kind of visualize this. Do you guys remember in geometry when you had to dilate images? So you could take a matrix, you can put in all the points,
You go through that.
and then you'd multiply the matrix and make it bigger or make it smaller. Or if you had to translate it, you would add to something else.
Kids who didn't take geometry don't.
So then that would produce the new set of ordered pairs that you would graph. Uh-huh. Keeps it simple. Cool beans? I can change the slide? Alright, you guys know these rules, right? The commutative property, the associative property, the additive property, the inverse property?
Yeah.
Do I need it? Do you guys need this slide or no? What happened? Oh, no, I have to do that. I can change it? Gone.
Okay.
Sarah, are you taking these notes?
Yeah, I'm watching, but I'm not writing.
Oh, look here. Look here. Here we have, they gave us two matrices. They gave us matrix A and they gave us matrix B. And then technically, this was the operator. This was the problem they asked us to do. They asked us to find negative 6B.
Which you're multiplying
Okay?
negative 6
Which
times,
is
right?
matrix B. This is called scalar multiplication. This is scalar multiplication. Scalar, not scalar. You're multiplying it by some scale. In this case, we're making the entire thing 6 times smaller. Okay, not scalar. Does not sound like a disease.
Sounds like
So like,
Okay.
is it like if the coefficient is a negative, it's gonna get smaller, but if it's
Well, yeah, I mean, we're multiplying by a negative number, right? So, which is kind of weird because, yeah, even though this is small, we're actually making it,
positive now, it's making it bigger.
yeah. We're doing the opposite of it 6 times, I guess. What is this, 12, negative 48, negative 30? So there's your new matrix. Are you okay with scalar multiplication?
Yeah.
Okay. Just for the sake of time, here's our next one. Go ahead and do that while I answer my phone call. Munoz. You got it. Eli. Alfono. Go. Did I say Eli? Are you Eli? Okay, then it's you.
I wonder who it is.
Process of elimination. Yay.
Hello?
They love everyone else but him.
are you
Oh,
gonna
hey.
choose somebody?
Oh, hey, it's my teacher.
What happened? Your desk? I don't know. I just saw that plastic bag in the chair and that was
Greg?
about it. But I don't know who went up front.
Take these notes, please.
What happened? I don't know. Because we were all just at the table. I didn't see no
Good? Alright.
But that's like bad news. I don't
So
know.
we're taking, what is this? Negative 12,
My,
9,
I'll take
3, 0.
I see no benefit.
We're adding that to negative 2,
Alright.
4, 16, 10. So our final matrix should read
Negative 14, negative, wait, 20, 25, negative 10, and then negative 1.
negative 10?
No, 10 and then negative 1. It's just that I was going left to right and you were going down and around.
How you do them is up to you. I always go randomly. Technically, you're supposed to go across like you read books,
Yeah.
but
I feel like down.
who cares?
So
Just get it right.
that's
No, that's a 0.
just scalar.
Is that scalar addition?
No,
So this is still
this is scalar multiplication and
And
addition.
Just regular addition.
Yeah, just regular addition, but it has scalar multiplication.
I like what you call it though. Scalar addition.
That can't be a thing.
No. It's kind of like combining multiplication and division. So you have scalar multiplication.
Can you add
It's just
like
addition.
numbers?
You're just adding them, but you're
Yeah.
multiplying. It's scalar
Yeah.
multiplication, but then you're adding.
Do you mean like 3 times b plus 5?
It's flickering.
Yeah. You just follow the order of operations. Multiply first, and then you add all the
Add
values.
5 to.
Everything.
Oh, okay.
That's what I was thinking.
Cool, huh?
This is kind of cool. Don't ruin my day.
I feel like I'm going to. I'm gonna move on.
Okay, go ahead.
I can go, right?
Yes.
Gone. All right, so some more rules for you. I think you should already know these. Associative property of scalar multiplication.
Yes.
What does associative property even mean?
You associate.
Doesn't mean you can move things. What the associative property is really saying is that math is only a binary operation. You can only multiply, in this case, 2 matrices before you have to get some answer and then multiply by the third. So please remember that. The associative property is all it's telling you is math is a binary operation. You can multiply A and B and then multiply to C, or you can multiply B and C and then multiply it to A. But there's no way we've learned how to multiply A, B, and C all at the same time.
Because you can't do that.
No, because you would always, regardless, end up multiplying the value A by B and then by C. Does that make sense?
Yeah.
Here, let me show you what I mean.
No, no, I know what you mean. I'm just like kind of thinking like, so how did you regular like, if there are numbers? 60. Okay. And you're one above like if it was just A times B, would you just multiply that?
No, this is just a new set of rules.
No, no, I know, right? That's what I was thinking.
Not when you have 2. Then if you have 2, then associative property does not apply. You'd have to have 3 things.
No, no, I know. I wasn't talking about this at all. Like I'm not confused about this at all. I'm confused about something else because I was thinking about like okay, go back to the other slide.
I need to go back to their slide.
Yeah. Okay. I'm thinking of what if you just multiply A times B, so you just multiply the same.
No. See, that's different.
See, that's what I was.
I'm going to get to that. Comitate. Comitate. I'm going to get back to that. Okay. So we're good here?
Yeah.
Okay. Here's what you were asking me about a minute ago. Ahem. This is what you're asking me about a minute ago. Solve for x. So in this case, we want to take 3x plus a is equal to b, and we need to solve it for what? You just read it for me. You ruined her. Okay.
Where is
So I have the formula 3x plus a is equal to b. Okay. What does a equal?
That.
Yeah, I know, but like, what are you, how are you supposed to?
So, oh,
Wait, I have an idea. Okay, if you subtract b, like you move the a to the other side and then you subtract it and then you divide it by 3.
that's fantastic.
Is that how you?
Before you drive yourself crazy plugging in numbers now, solve it for x the way it is. 3x is equal to b minus a divided by 3. Now, do we really divide?
No, we multiply
No.
by 1/3.
So here's what's going to happen. You're going to have x is equal to 1/3 multiplied by the difference of b and a, hence my distributive property, or whichever way you want to go about it. So now in this case, I know I got to go b minus a, don't I?
Yeah.
So let's go and find that matrix real quick right over here. So b minus a, I've got negative 12. 1 minus a negative 8. That gives me 9. Negative 9 minus 0 is still just negative 9. 17 minus 4 is 13. So there's my matrix. That is B minus A right there, correct?
Negative 4, 3, negative 3, 3 over 13 over 3.
Right? So that means that X is equal to negative 4, 3, negative 3, and 13 thirds.
That was easy. It's a lot easier than I expected it to be.
Okay. Now, I'm going to add a slide here. Should I wait?
What is that? Still scalar or what?
No, we're solving the equations here.
Oh,
See how we solve this equation?
yeah.
So now I'm going to answer your question. Let's see here. I want to take a matrix and I want to multiply it by another matrix. So this is not scalar multiplication. I'm taking the matrix and I'm multiplying it by another matrix. This is the harder part. This is the hardest thing to
What's it
do.
called? Why can't you?
Matrix multiplication.
Oh, okay.
No, because there was multiplication a minute ago. That one's
That
called
was
scalar.
scalar.
That one's called scalar. Okay?
This one's called.
Here you're just multiply matrices.
Okay.
Oh, there's 3 of you. Super cool. You guys are dressed in sugar.
What?
Oh, us 3. Oh.
My cheer squad up here.
So confusing.
You guys ready?
Are good.
Okay.
Yeah, I'm ready to struggle.
It's no struggle. We got 5 minutes?
Yeah.
Ah!
Go.
Alright, so let's say I had 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So we had that a minute ago. Are those equal?
Yes.
Yes, they are equal. Can I multiply them?
Yes.
The answer is no.
Hold on. You're going too fast.
Because they're the same thing.
You can't write.
That doesn't make sense.
Okay. So we all agree that these are equal. I can add them, I can subtract them, but I cannot multiply them. Okay? Because the way you multiply matrices, here's your rule for you. You guys remember the orders? What's the order of matrix A here? It's a 2 by 3, right?
Yep.
And this is also 2 by 3? So I'm about to give you this rule. In order to be able to multiply matrices, the inside values have to match. So set them up, put them side by side, just like I did. And these two must match. So the inside ones must match.
So I have to take 2 by 3 and 3 by 2.
Yes. Okay? So I'll give you an example. I can go plus, right? So could I take a 2 by 4 and multiply it by a 4 by 3?
Yes.
Yes. Could I take a 2 by 2 and multiply it by a 2 by 1?
Yes.
Yes. We'll get to that. I just want to make sure you understand these rules first. We probably won't be able to do it, but I want you to understand the rules. Okay? Now, and we'll do it tomorrow probably after the writing final. Okay?
We don't get to go last one.
You need, oh, never mind. You're right. Now, just an FYI, these can be done, correct?
Yes.
So this can be done. Once you finish, your resulting matrix will be the dimensions of the outside two. So if I multiply this 2 by 4 with a 4 by 3, then my answer will be a 2 by 3.
Oh, okay, I got it.
Okay.
Yeah.
So it's going to be the bigger values? Like that
If the insides match, I get what's on the outside. So what would I get as a matrix here for this 2 by 2 with 2 by 1? I would get a 2 by 1. Okay?
So it's whatever which one's on the far right?
So let's do this real quick here. If I did a 4 by 3 with a 3 by 2, can I do that? Yes, because these match, and I would end up getting a 4 by 2 as a solution.
Oh!
Okay? All right. Do we have time? Hold on.
No, it's 2 minutes.
I have 2 minutes. Give me 2 minutes. So, here it is. Can this be done?
Yes. Yes.
This is a 2x2 with a 2x4. Can I do it?
Yes.
What am I going to get at the end?
2x4.
This is how you do it. So, and hopefully I can get through it so you can understand what's going to happen. If it doesn't, we can try to answer some questions right now, tomorrow. I want to find, nope, I can't. Question? You have a,
Yeah, but it's called.
I was on campus, but I didn't know this. But I wasn't sure if I need to be here tomorrow.
oh, I should stop this. It's still recording.